Chapter 9. Estimation. In many business situations, decision makers need to know a population parameter. Unfortunately, if not impossible, gaining access to an entire population may be too time-consuming and expensive to be feasible. In such situations, decision makers will select a sample and use the sample data to compute a statistic that estimates the population parameter of interest. The decision maker needs to use procedures that ensure the sample will be large enough to provide valid estimates of the population parameter and needs to be confident that the estimate matches the population parameter of interest. Point and confidence interval estimates. Whenever it is impossible to know the true population parameter, decision makers will rely on a point estimate. A point estimate is a single statistic, determined from a sample that is used to estimate the corresponding population parameter. Point estimates are subject to sampling error, which is the difference between a statistic and the corresponding population parameter. Sampling error cannot be eliminated, but it can be managed in the decision-making process by calculating a confidence interval. A confidence interval is an interval developed from sample values such that if all possible intervals of a given width are constructed, a percentage of these intervals, known as the confidence level, would include the true population parameter. A confidence interval can be calculated using the general format below: point estimate plus or minus critical value times standard error. The size of the sample and the confidence level chosen will have an impact on the interval estimate. The point estimate depends on the parameter being estimated. The critical value depends on the parameter being estimated and, for example, in the case where the population mean is being estimated, whether the population standard deviation is known or not. The standard error measures the spread of the sampling distribution. The amount that is added to and subtracted from the point estimate to determine the endpoints of the confidence interval is referred to as the margin of error. Lowering the confidence level is one way to reduce the margin of error. The margin of error can also be reduced by increasing the sample size. When estimating a population mean, it is necessary to distinguish between those cases where the population standard deviation is known and those cases where it is not known. When the population standard deviation is known, the population mean is estimated using a critical value from the standard normal table for a specified confidence interval. When the population standard deviation is not known, the critical value is a t-value taken from a family of distributions called the student's t-distributions. The specific t-distribution chosen depends on the number of independent data values available to estimate the population standard deviation, a value known as the degrees of freedom. Determining the required sample size for estimating a population mean. A common question asked by decision makers who are conducting an estimation of a population parameter is, how large a sample size do I need? The answer to this question depends on the resources available for sampling and the cost to select and measure each item sampled. The answers to these two questions will provide an upper limit on the sample size that can be selected. Before a definitive answer regarding the sample size can be given, the decision maker must also specify the confidence level and the desired margin of error. If the population standard deviation is unknown, one option may be to select a pilot sample, a sample taken from the population of interest of a size smaller than the anticipated sample size used to provide an estimate of the population standard deviation. Outcome 1. Distinguish between a point estimate and a confidence interval estimate. Outcome 2. Construct and interpret a confidence interval estimate for a single population mean using both the standard normal and t-distributions. Outcome 3. Determine the required sample size for estimating a single population mean. Estimating a population proportion. In many situations, the objective of sampling will be to estimate a population proportion. The confidence interval estimate for a population proportion is formed using the same general format to estimate a population mean. Point estimate plus or minus, critical value, times, standard error. The critical value for a confidence interval estimate of a population proportion will always be a z-value from the standard normal distribution. Changing the confidence level affects the interval width. Likewise, changing the sample size will affect the interval width. An increase in the sample size will reduce the standard error and reduce the interval width. As was the case for estimating the population mean, the required sample size for estimating a population proportion is based on the desired margin of error. Conclusion. Many decision-making applications require that a decision be based on a sample which is used to estimate a population parameter. There are two types of estimates: point estimates and interval estimates. Point estimates are subject to potential sampling error. Point estimates are almost always different from the population value. A confidence interval estimate takes into account the potential for sampling error and provides a range within which we believe the true population value falls. The general format for all confidence interval estimates is point estimate plus or minus, critical value, times, standard error. The point estimate falls in the center of the interval. The amount that is added and subtracted from the point estimate is called the margin of error. While the format stays the same, there are differences in the formulas used depending on what population value is being estimated and certain other conditions. The figure provides a useful flow diagram for the alternative confidence interval estimations discussed in the chapter.